invertebrate presentations today.
I'll be right back.
But I do have a good reason to talk about horseshoe crabs. I am a biologist at New York State DEC, Division of Marine Resources, and I coordinate our New York Horseshoe Crab Monitoring Network, which is our spawning survey for the entirety of New York waters. I'm very excited. I'm a little biased. I've been helping with spawning surveys since I was a kid in high school, and I'm very excited to share the results of these with you, the history, and how it helps inform our management decisions. So horseshoe crabs, really interesting creatures. They're ancient mariners. If you don't know about them, they're as old as dinosaurs, survived multiple extinctions. They have a very interesting life history. They molt about 18 times until they become sexually mature. And then when they are sexually mature, they will aggregate in these large groupings and come up on the beaches to spawn and mate and lay their eggs. So horseshoe crabs are important for a variety of different reasons. Primarily in New York, they're used as bait in the American eel and whelk fisheries. So they're really big in the bait fisheries, which really shows the interconnectedness of the fisheries. But they are also used in the biomedical industry. Their blood is blue. It's actually a copper-based blood compared to like our red iron-based blood. And it's the FDA gold standard in the biomedical industry to test out vaccines for any negative pathogens and also any medically implanted devices. So that has been a standard for decades. But very important to know, for New York, there are no biomedical permits issued, and there have never been. So New York is only a bait fishery. But they're also important for a lot of ecosystem services. So their eggs are actually used as a food source for migratory shorebirds that are traveling up and down the coast, as you can see, mainly our endangered red knot there. And they provide a big food source for that long migration. So the spawning survey was initiated in 2008 with concerns of horseshoe crab declines and also migratory shorebird population declines. And the spawning survey was initiated in collaboration with DEC, Cornell Cooperative Extension, and Stony Brook University's SOMAS program. And the goal was to ultimately create a quantitative assessment to get that quantitative data to ultimately help inform management and conservation decisions. So the survey has grown to 30 sites along mainly New York, but it's all the way from Staten Island to Fisheries Islands. And for our data, it's broken up into our 4 different spatial zones. So we got our Long Island Sound, North Shore, we got our what we call our Jamaica Bay, but that also includes New York Harbor, Raritan Bay, our South Shore estuary bays, and also our Peconic estuary sites. This, again, is a citizen science survey, so without the over 800 volunteers, we would not be able to do as many sites and get all this great data. So always need to thank our volunteers and our trained site coordinators who help lead those volunteers at our sites at midnight for a nice stroll in moonlight. So they do a great job. This is just the homepage for our website for anyone who is ever interested to get involved, and also if you have a site that you think could be a potential monitoring site, that is any way to contact us to let us know. So the survey is a 12 sample night in May and June, coinciding with the new and full moons during those evening high tides. So this is just an example in Big Egg, Queens. You got our normal 12 sample nights following that high tide time. So yeah, we got a nice big snapshot around those high spawning times. Horseshoe crabs will spawn outside of these full and new moons, but these are just their peak spawning periods where we're trying to get consistent data. This is just an example of one of our sites in South Harbor. So our volunteers will start at one end of a transect that's pre-measured, and they will walk continuously, counting every single horseshoe crab that they come across. There is no backtracking. They go in a continuous, straight movement. So this is just an example of what some of our volunteers might be seeing. So we got this nice grouping of horseshoe crabs in our surf zone. So they'll see either and count if they're found in the surf zone, if they're in the submerged zone, completely submerged underwater, and they'll count all the horseshoe crabs and also say if they are female or male. So you can see one female surrounded by 4 males. Easiest way with that is generally females are going to be much larger than the males, usually surrounded by multiple males, or at least have one attached. Easiest way really, if you are ever confused, is if you gently flip them over, not by their telson or their tail. The females will have a regular scissor-like appendage, just like the rest of the legs for their first appendage, but the males will have what's considered a boxing glove or with a hook on it that they use to attach the back of the female for mating. That's a surefire way to know if it's a male or female. So seems pretty simple, right? Not too bad. So this is actually taken from this past year. This was me. In 2025 at one of our sites at Jones Beach on the South Shore. And that is a lot of crabs. So this night it was actually over 1,000 crabs for that transect. So our volunteers are dedicating over an hour counting these crabs. So it's a lot. And some of our sites, because of these large aggregations, will actually use quadrat method, which will be a subsample of those. And they do that as specific steps and counts. I'm not even going to get into all the nitty-gritty of the methodology of that, but there are certain sites that have that quadrat subsample method. After our general survey, then we will go into tagging. We get Fish and Wildlife Service button tags, and we will tag as many crabs as we can see, all done after the survey so it doesn't affect how many crabs we're seeing as we're walking that transect line. So data collected with that includes sex, carapace width, shell condition, and epiphyte coverage, so any of the barnacles or slipper snails that are found on the shells. And for New York, we tag 5,000 a year. So it's a lot of tagging. If you ever see a horseshoe crab with a tag, please report it to Fish and Wildlife Service. This is a lot of great data. It might not look as pristine and white as when we first set it out. It'll look all algae and probably green. But you also will get a pin from Fish and Wildlife Service for recovering a tag. And you get a nice history of where that horseshoe crab was released. So it's really cool and interesting. And all that data is then used in marker capture. So this is using tagging data from 2007 to 2016, breaking it into 3 geographic states, the Jamaica Bay, North Shore, and South Shore. And we get really interesting information, such as the survival estimates. So we can see that North Shore actually has the highest survival rate compared to the other 2. It's actually on par with Delaware Bay horseshoe crabs, which is considered the epicenter for horseshoe crabs on the East Coast. Jamaica Bay is the lowest, with South Shore being slightly higher. South Shore could take into account harvest. So horseshoe crab harvest is mostly in the South Shore bays. Jamaica Bay, there is no harvest. So there's something interesting going on there, something to think about. But there's also migration rates, so between these estuaries, there's actually limited exchange between the estuaries. We find that the horseshoe crabs actually stay within their tagged region that they were first released in. So when they're recaptured, they're being found in that same estuary and geographic region. So overall, the other spawning trends that we're seeing, so splitting again into those 4 geographical spaces, we got Jamaica Bay, South Shore, North Shore, and Peconic Bay. And this is the indices of spawning activity of female horseshoe crabs. And using just linear regression, we're looking at 5-year and 10-year trends. So we're seeing increasing and stable trends in those 5 and 10-year marks. So overall, we are seeing general increase in spawning abundance in horseshoe crabs in each of these regions. So how can these trends be used to inform management decisions? Little history of management. So DEC's overall goal is to improve the stock status of horseshoe crabs and create a balanced, sustainable fishery with the broadest range of uses. So that includes ecosystem services, commercial harvest, and observation and appreciation. Horseshoe crabs are managed under the Atlantic States Marine Fisheries Commission, the Fisheries Management Plan. So going into the history, the Commission first developed the Fishery Management Plan in 1998. Then the Commission set state-by-state quotas for each state that were harvested for bait. New York got just over 366,000 crabs for their quota. In 2004, DEC voluntarily reduced that quota to less than half of the FMP's allowable take, so 150,000 crabs annually, due to overall concerns of abundance and population. And then most recently in 2020, DEC implemented 2 5-day lunar closures to help protect horseshoe crabs that were going on the beach during those peak spawning periods so that they could lay their eggs undisturbed. Then DEC developed regulations of using bait bags in the whelk pots to help use less horseshoe crab bait as needed. And then lastly, DEC implemented 2 additional 5-day lunar closures to coincide with all of those new and full moons in May and June. Other regulations include permitting requirements, reporting requirements, and also closed areas. So we have a few closed areas. We've got West Meadow Beach closed area, Cedar Beach and Mount Sinai, Fire Island National Seashore, and Gateway National Recreation Area, which is, again, that almost entirety of Jamaica Bay. So looking forward, horseshoe crabs, like I said, are a long-lived species, and they really sexually mature after about 10 years. So any change in abundance of spawning age crabs isn't going to be seen until after that 10-year cycle. So any abundance wasn't expected to change, especially after the 2024 benchmark update. There's actually empirical data from Delaware Bay that shows that it takes 10 years to see a population response in response to harvest reductions. We're hoping and we're expecting to see an increase in aged spawning adults around 2030 or later based on the lunar closures, so that 2020 and 2025 additional lunar closures. We also have precedent from Massachusetts. They implemented their lunar closures back in 2010, and now, 10 years later, starting to see that increase in crabs. Also, looking at full picture, there are other issues that could be affecting horseshoe crabs and also many other species. So, habitat changes could be impacting the recovery of these potential species. So, shoreline hardening, sea level rise, beach replenishment activities. Habitat loss is actually identified as the long-term key conservation challenge. That was by Smith et al. That came out this past year. Loss of spawning habitat may prevent recovery back to those 1998 levels when the FMP was first put together. This is just an example. So this is the Peconic Estuary, and it's actually bulkheads increased threefold from 2000 to 2016. So this was actually an aerial study, but it does have a ground truthing survey that is currently underway. So looking into overall, it's important to look at multiple factors that could be impacting horseshoe crabs in general. Both habitat and harvest need to be managed at a proper level to restore these to a historical level. So giving into current happenings, while our data doesn't show an urgent need and more of a patient approach, the legislation found that need for further protections, and Governor Kathy Hochul signed a bill on December 19th, making a phase out of the fishery until January 1st, 2029, where there will be a full moratorium in effect for horseshoe crabs in general. This phase out will take place over the next 3 years, taking about a 25% each year from that 150,000 quota. So at this time, DC will still actively manage the fishery with the best available science and follow our fisheries management plan through the commission. DC and CTUC Environmental Association are supporting Cornell Cooperative Extension in an alternative bait study to find an alternative bait for our fishermen. At this time, there is no viable alternative bait for fishermen to use. Those results are expected in early 2027. And ultimately, we will still be doing our spawning survey, getting that data. We are expecting, again, lots of results in 2030 and later. So I always say, if you're very interested in joining, we would love to have you. And it's a great opportunity, and it's a really good thing for people who are into fisheries management to see different sides and multiple shareholders involved and the collaboration it takes. So thank you very much. This video was taken by our drone team in Moriches Bay in this past year in Pikes Beach. So it's very exciting. Yes.